AudioJungle.
An oscilloscope's trigger function synchronizes the horizontal swipe at the correct point of the signal. This is essential for clean signal characterization. Trigger controls allow you to stabilize repetitive waveforms and capture single-shot waveforms. The trigger makes repetitive waveforms appear static on the oscilloscope display by repeatedly displaying the same portion of the input signal. If each swipe started at a different place on the signal, the jumble that would result as the screen shows. Open Main Menu to select each trigger, which is the basic and most common type. The trigger circuit acts as a comparator. You select the slope and voltage level of one side of the comparator. When the trigger signal matches your settings, the oscilloscope generates a trigger. The level control determines where on the edge the trigger point occurs. The slope control determines whether the trigger point is on the rising or the falling edge of a signal. The trigger mode determines whether or not the oscilloscope draws a waveform if it does not detect a trigger. Common trigger modes include normal and auto. In normal mode, the oscilloscope only swipes if the input signal reaches the set trigger point. Otherwise, the screen is frozen on the last acquired waveform. Normal mode can be disorienting since you may not see the signal at first if the level control is not adjusted correctly. Auto mode causes the oscilloscope to swipe even without a trigger. If no signal is present, a timer in the oscilloscope triggers the swipe. This ensures that the display will not disappear if the signal does not cause a trigger. In practice, we will probably use both modes. For normal mode, because it lets us see just the signal of interest, even when triggers occur at a slow rate, and auto mode because it requires less adjustment. Oscilloscopes also include special modes for single swipes, which we call SEQ single. Just as we can select either AC or DC coupling for the vertical system, we can choose the kind of coupling for the trigger signal. Besides AC and DC coupling, our oscilloscope also have high-frequency rejection, low-frequency rejection, and noise rejection trigger coupling. These special settings are useful for eliminating noise from the trigger signal to prevent false triggering. Sometimes getting an oscilloscope to trigger on the correct part of a signal requires great skill. Many oscilloscopes have special features to make this task easier. One is trigger hold-off, an adjustable period of time during which the oscilloscope cannot trigger. This feature is useful when you are triggering on complex waveform shapes, so that the oscilloscope only triggers on the first available trigger point.